You kneel down in your garden and pick up a handful of soil, and it falls apart in your fingers like dust, pale, cracked, almost lifeless. You have been feeding it fertilizer every season for years, and every season it needs a little more just to produce the same tomatoes. The United Nations has actually measured what is happening under your feet. A third of the planet's soil is already degraded, and the Food and Agricultural Organization warns that number could reach 90% by 2050. It takes roughly 1,000 years for nature to build a few centimeters of topsoil, and right now, the world is losing the equivalent of one entire soccer field of it every 5 seconds. And in the middle of the Amazon rainforest, in soil so poor that the jungle around it can barely sustain itself, archaeologists kept finding patches of ground that broke every rule. Black, rich, deep, and still growing lush crops today, thousands of years after the people who made it disappeared. What I'm about to show you is the technique that created it, a technique modern industrial farming abandoned completely. And by the end of this video, you are going to know exactly how to bring it back into your own backyard for close to nothing. Here is the problem hiding under almost every farm and garden in the developed world: the fertilizer bag. Synthetic fertilizer feeds a plant directly. Nitrogen, phosphorus, potassium, dissolved and ready to absorb. It works. Your tomatoes get bigger. But here is what almost nobody connects to their own yard. Most of that fertilizer does not stay where you put it. It dissolves in the first heavy rain and washes straight through soil that has no structure left to hold it. Because synthetic fertilizer feeds the plant, but it does almost nothing for the soil itself. It does not feed the microbes, the fungi, and the organic carbon that gives soil its actual structure, the structure that holds water and nutrients in place. So the soil keeps thinning, keeps flattening, keeps losing its ability to hold anything on its own. And next season, you need fertilizer again, in a slightly higher dose, to get the same result. You are not fixing the soil. You are running it on life support and paying for the privilege every single spring, every year. That is the system almost every home gardener and small farmer has been taught to accept as normal, and it is only about 70 years old, which is exactly why what a Dutch soil scientist named Wim Sombroek found in the Amazon in the 1960s mattered so much. Sombroek was mapping soils across the Amazon basin when he kept running into small, isolated patches of something that should not exist there. The surrounding rainforest sits on some of the most nutrient-poor, heavily weathered soil on Earth. Soil so thin that once the forest canopy is cleared, it can barely support a few seasons of farming before it collapses. But scattered through that same landscape were patches of soil the local population called terra preta, black earth, dark as coffee grounds, packed with broken pottery, and still fertile enough to farm continuously without any modern fertilizer at all. Later research, led by scientists including Bruno Glaser and Cornell soil scientist Johannes Lehmann, confirmed just how strange this soil really was. Terra preta contains up to 70 times more stable carbon than the ground around it, and radiocarbon dating shows some of these plots have stayed fertile for centuries, in some cases well over 1,000 years after the civilization that built them vanished. So what did they actually do? Not magic, not some lost mystical fertilizer. Ancient Amazonian communities were burning organic waste, crop residue, wood, food scraps, at low oxygen instead of open flame, which stopped it from turning to ash and instead turned it into charcoal. They mixed that charcoal into the soil, along with bone, broken pottery shards, fish remains, and manure, and buried it. Modern science now has a name for that charcoal component: biochar. And here is the part that changes
everything once you understand it. Charcoal, at a microscopic level, is riddled with tiny pores, an almost impossibly large internal surface area packed into a small piece of material. Fresh organic matter breaks down and washes away within a few seasons. Charcoal does not.
It sits in the soil like a honeycomb of microscopic apartments, and those pores become permanent housing for soil microbes and permanent storage for water and nutrients that would otherwise leach straight through. That structure does not rot away in a decade. It persists for centuries, which is exactly why terra preta has stayed fertile for so long after everyone who built it was gone. Now here is the detail almost every home gardener gets wrong when they try to recreate this, and it is the single variable that determines whether biochar helps your garden or actually hurts it for a season. Raw charcoal straight out of the fire is essentially empty. All those microscopic pores are vacant, and if you bury empty charcoal directly into your soil, it will actually pull nitrogen away from your plants for a while, as it slowly fills those pores from the surrounding ground. The Amazonians never used it raw. They mixed it directly with manure, food waste, ash, and bone before it went into the soil. Modern researchers call this step charging the biochar, essentially soaking it in compost tea, manure, or urine for a couple of weeks. So every one of those microscopic pores is already loaded with nutrients and microbial life before it ever touches your garden bed. Charged biochar feeds your soil immediately. Uncharged biochar borrows from it first. That single step is the difference between a technique that built rainforest civilizations and a bag of expensive black dust doing nothing in your yard. And Cornell's Lehman Lab, after decades studying this exact material, published something remarkable. Across a global meta-analysis of field trials, properly applied biochar increased crop yields by about as much as synthetic fertilizer. And in soils that had stopped responding well to fertilizer altogether, biochar performed even better because it was rebuilding the structure fertilizer was never designed to touch. Here is what that means for your own backyard, and the cost is almost embarrassing compared to what you are already spending. You do not need to fly to Brazil or buy a bag of commercial biochar for $30. Farmers have been making it for generations, using nothing more than a metal drum or a shallow pit, a controlled burn of brush, wood scraps, and yard waste, starved of oxygen once it gets going, then doused with water the moment it turns to charcoal instead of letting it burn down to ash. Crush what is left into pieces the size of gravel. Soak it for 1 to 2 weeks in compost tea, diluted manure, or even your own urine, which is free and surprisingly rich in nitrogen, and then work it into your soil. What used to be brush pile waste becomes centuries of soil structure for the cost of a Saturday afternoon and materials you likely already have sitting in your yard. Compare that to the alternative. The global synthetic fertilizer industry is worth more than $200 billion a year, and every single dollar of that market depends on you needing to buy more of it every season, forever. Because fertilizer alone was never built to fix your soil, only to temporarily feed what is left of it. Nobody in that industry profits from telling you that a pile of charred yard waste, properly charged, builds soil that needs less of their product every year that passes. This was never a secret unique to the Amazon either. Independently, thousands of miles apart, other civilizations arrived at the same discovery. Farmers in Japan have used a charcoal soil amendment called kuntan for centuries to lighten and enrich rice paddy soil. Across parts of Europe, centuries of manure, ash, and household waste worked into feeds created what soil scientists now call plagin soils, dark, carbon-rich earth still more fertile than the ground around it. In parts of Australia, researchers have identified charcoal-enriched dark earths dating back thousands of years, now known as Terra preta australis.
None of these cultures were in contact with each other. They all reached the same conclusion through trial and error, generations before anyone had a microscope to explain why it worked. Burn it low, bury the char, and the ground remembers. Modern industrial agriculture did not disprove any of this. It simply replaced it, because a bag of synthetic fertilizer is faster to sell than teaching a farmer to build soil structure that pays off for centuries. The physics of a microscopic charcoal pour holding water and nutrients in place has not changed since the Amazon. The technique did not disappear because it stopped working. It disappeared because nobody profits from a soil amendment you can build for free out of your own yard waste. So the next time you are standing in your garden looking at soil that needs another bag of fertilizer just to keep up with last year, remember what is sitting in that brush pile you were about to burn down to ash or haul away. It was never trash. It is the exact same material that has kept patches of Amazon soil fertile for over 1,000 years after the people who built it were gone. If this is the kind of thing you actually want to know about your own backyard, instead of waiting for someone to sell you the expensive version of it, tell me in the comments if you have ever tried biochar and what happened. Subscribe, because the next lost technique we uncover makes this one look like the warm-up.